that value. Okay? Any questions on this? So on this interval, when is the particle traveling to the left? How do you know if it's traveling to the left? Velocity less than 0. Velocity has to be negative. But in this case, the velocity is x prime of t. When is this negative?
At 0. When the particle is at 0. So when t equals 0.
So name 2 places that the particle will be traveling to the left. At -2 and at 0. What about at 4? Traveling to the right because it's positive. Also here traveling to the right because it's positive. What about at 1? Does not exist, meaning I don't know what it's doing. Okay? So looking back up at the top, it has one critical point. And that critical point is this. This is a critical point. Because like we said before, what does it take to be a critical point? Oh, I didn't talk about that today, did I? Just kidding. When the derivative is 0 or undefined. Undefined. Okay, so when is it traveling to the left? So where do you think this, so do you think just saying that at x equals -2 and at 0, do you think that's going to be good enough?
No.
Why not?
They want you to probably figure out exactly at what point it started warming up.
Well, they want an interval. Right. So this is just 2 places, but for all values, where is this going to happen?
Wouldn't it be from when t is greater or less than 1?
So the key place that we're looking is at x equals 1, or at t equals 1. The reason t equals 1 is so important is because it's a critical point. It's undefined here, so that means that's where x prime changes a lot. Okay, so notice how x prime is negative, x prime is negative, and then it changes to positive. We know that that's a critical point because of this. Okay, and we also know that it's the only critical point. That means it can't have another change somewhere else. Because if it were to change somewhere in between -2 and 0, it would also be a critical point. Or if it changed over here, it'd also be a critical point. But there's only one critical point, and it's at 1. So that means all the changing of x prime is going to happen at t equals 1. So I'm either going to say for t less than 0 or t less than 1 or t greater than 1. I know it's not happening at 1. This should have been t. So what do you think? T less than 0 or t less than 1 or t greater than 1? It's going to happen in this area. Right. So in what interval? In the interval, when is the particle traveling to the left? When t is less than 1. Now, what would be a good justification for that? Try to just explain why. I just gave you the explanation, but if you had to re-explain it, what would be your answer? Say that again? So we are going to have to point out something about 1. What's important about 1? That it's a critical point. So we should say, we can just say this: when t is less than 1, that's our answer. Our justification will be, since t equals 1 is a critical point, what else did we point out? How did we know that it was negative, that it was traveling to the left over here? Because we looked at a couple points of the velocity, so we need to point that out too. So since t equals 1 is a critical point, and so cite a few points as evidence. What are the 2 points that we cited as evidence? Negative 2 and 0. So we could say that. Well, the better thing is we're looking at for x prime. So x prime of negative 2 since t equals 1 is a critical point, and x prime of negative 2 is negative. And good, so both points, and x prime of 0 is negative, less than 0. X prime of t will be less than 0 for all values. For all, well, we could put t values, just for all t values on what interval? Well, it is negative 2, but it doesn't go all the way up to well, up to 0 will be correct, but it goes all the way up to 1 because that's the critical value. Because what we had done is we checked it at 0 and we checked it at negative 2. X prime was negative here, x prime was negative here. But what we're trying to say is that it's going to be negative all the way from negative 2, not just to 0, but where? Up to negative 1, not including, because I don't know what's happening at 1. It's undefined. Does that make sense? So it's all the way from negative 2 up to 1. Because you wouldn't get all, see what you would happen. It would look like this. If you said 0, you would be saying, oh, it's only from negative 2 to 0. But you're leaving out all this other space, which was also negative. Okay, justification's hard. I mean, I see it very much like an essay. You know how an essay, you have to be very specific in your evidence. Like you have to say, this is a piece of evidence, and then you have to say why it's important. You can't just throw it out there and say, evidence. You have to explain why it's important. I tend to just throw out evidence. Does the particle reach a relative minimum or a maximum?
We do that chart.
Okay, so first, what do you think? Yes or no?
Yeah, the sign chart.
Right, we already started the sign chart a little bit. What's going to be my critical value? 1. So I'm going to be looking at x prime and at x. At 1, is it 0? Is x prime 0? X prime is dne. If x prime is dne, I don't know what's going on here yet. But I do know what's going on left and right of this. To the left, what's happening? We already analyzed this. It's negative to the left and positive over here. So if it's negative, that means it's decreasing. Positive means it's increasing. So what would you have here? It would be a relative min. If it's decreasing, then increasing, you have a relative min.
But since it's GNE, could it possibly be like an asymptote?
Yes, and that's where it becomes tricky. Could be a relative min. Could be an asymptote. Okay? Okay, look for the YouTubes and study.